Hello everyone, welcome to the certificate course on reasoning and quantitative techniques. In this video, we are going to discuss about the quantitative aptitude topic, probability. In the previous video, we have already introduced what is probability, how to find probability of any event which is given using the combination. So in this, we are going to explain some more application part of the probability like addition rule of probability, condition probability and all. Addition rule of probability. If A and B are any two events, then the probability of occurrence of either A or B, or we can also say it as at least A or B, is given denoted by P of A union B is P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A intersection B is probability that both event will happen. In a town, 15% of population read newspaper A, 13% of population read newspaper B, 8% read newspaper A and B. Find the probability that a person selected in random shall read either paper A or paper B. So let us take A as people who read newspaper A and B as people who read newspaper B. So it is given that probability that people A will read is 15%. So probability will be 15 by 100. So 13% will read probability newspaper B. So probability of B will be equal to 13 divided by 100. And also given that 8% read both newspaper A and B, so that is denoted by A intersection B is equal to 8 by 100. So since we have to find probability of people who read either A or B, so that is denoted by probability of A union B. So using addition rule, we have probability of A plus probability of B minus probability of A intersection B. So that will be equal to 15 by 100 plus 13 by 100 minus 8 by 100. So that will be equal to 15 plus 13. We have 28. 28 minus 8. That is 20 divided by 100. That means 20% of the people read either A or B. Next question. The probability that a student passes an accounting test is 2 by 3 and probability that he passes both accountancy and law test is 14 by 55. The probability that he passes at least one test is 4 by 5. What is the probability that he passes in the law test? Okay, let us take event A as probability that he passes accountancy test. Okay, and event B has a probability that he will pass law test. So what is given? Probability that he passes accountancy is given. P of A is 2 by 3. Probability that he will pass law test is not given. Probability that he will pass at least one test, A union B. Okay, this is at least one test is given as a 4 by 5 and probability that he will pass both accountancy and law test A intersection B is 14 by 45. So now we have this addition rule of probability. A union B is equal to probability of A plus probability of B minus probability of A intersection B. If you substitute A union B is 4 by 5 equal to probability of A is 2 by 3, probability of B is not given, minus intersection is 14 by 15. In order to simplify, we make so this is 14 by 45. We make the denominator common, that is, we'll make 45. So to make this, multiply this by 9 into 9, multiply this by 15 by 15. So we have 4 nines are 36 divided by 5 nines are 45 is equal to 2 15s are 30 divided by 3 15s are 45 plus P of B minus 14 by 45. So P of B will be equal to 36 by 45 minus 30 by 45 plus 14 by 45. So P of B, probability that he will pass law test, is equal to 36 minus 36, 6 plus 14 is 20 divided by 45. So probability that he will pass law test is equal to 20 by 45, that is 4 by 9. A card is drawn from a well-shuffled pack of playing cards. It is find the probability that the card is either a king or a spade, king or black card, spade or a heart, king or queen card. Now, there are total 52 cards in a deck. So, since we are picking only one card, so we have 52 C1. So, number of element in the sample space is 52. So, let us denote first one either king or spade card. Now, probability that the card will be king. So, there are total there are total 4 king cards divided by 52. Probability that it will be a spade. Okay, there are total 13 spades, so 13 by 52. Probability that card will be both king and spade. So a spade has one king in it, so it will be 1 divided by 52. So the probability that either king or spade, so K union S, will be probability of K plus probability of S minus probability of A intersection S. That is 4 by 52 plus 13 by 52 minus 1 by 52, which is equal to 4 plus 13, 17 minus 1. So 16 divided by 52, which is equal to 0.307. Okay, next we have second question. King or black card. The second one is king or black card. Again, probability that card will be a king. There are 4 kings, so 4 by 52. Probability that it will be a black card will be there are 26 black card out of 52. Probability that card will be both king and black. So there are total 2 king card which are black in color. So probability will be 2 by 52. Therefore, probability that the card will be either king or black is K union B is 4 by 52 plus 26 by 52 minus 2 by 52. So that will be 28 divided by 52. So 0.535. The third one, probability of either spade or heart. The probability that card will be either spade or heart. Probability that card will be spade. There are total 13 spades. So probability is 13 by 52. Probability of heart. Again there are total 13 heart out of 52. Probability that a card will be both heart as well as spade. If there are no such cards, the probability is 0. Therefore, the card will be either spade or heart will be equal to 13 by 52 plus 13 by 52 minus 0. So that will be 26 by 52, 0.5. And fourth one, what is the probability that card will be king or queen? Probability that card will be king. So there are 4 king cards. So probability will be 4 by 52. And there are 4 queen cards. So probability will be again 4 by 52. Probability that card will be both king and queen. There are no such cards. The probability is 0. The probability that card will be either king or queen will be equal to 4 by 52 plus 4 by 52 minus 0, 8 by 52. That is 0.1538. Okay, then we have conditional probability. Conditional probability of an event B given A is the probability of happening of event B when it is already known that event A has already occurred. And the formula is given by condition probability of P given A. Probability of A intersection B divided by probability of B, where probability of A should be greater than 0. Conditional probability of A given B is equal to probability of A given B is probability of A intersection B divided by probability of B, provided probability of B should be greater than 0. Multiplication theorem. When the events are independent, the probability, like for example, cards drawn with replacement. You pick a card, you replace it back, then pick the next card. So here picking first card and second card becomes independent event. The probability that both event A and B will happen is given by probability of A into probability of B. When the events are dependent, like you after picking a card, you do not replace it, then you pick the second card. The cards are drawn without replacement. Here probability of A intersection B will be equal to probability of A into conditional probability of B given A. Okay, let's solve from problems here. A dice is rolled. It is, if the outcome is an even number, what is the probability that it is a prime number? So when a dice is rolled, the number of possible outcome, we have n of s equal to 6. We have outcomes 1, 2, 3, 4, 5 and 6. Okay, let event A is that it is a prime number. Event B is that it is an even number. We have prime numbers are 2, 3 and 5. So we have to, A is given here, right? A is given. We need to find what is the probability of B when it is known that A is already occurred. What is probability of B given A? So formula is probability of A intersection B divided by probability of A. Here, there are 3 are prime numbers out of 6. So probability of A will be equal to 3 divided by 6. Or you can write 1 by 2. Now, probability of A intersection B. So here even number, we have 2, 4, 6. So here for A and B, the intersection is only 1, that is 2. Therefore, probability of A intersection B will be 1 divided by 6. Therefore, probability of P given A will be equal to 1 divided by 6 divided by 3 divided by 6, that is equal to 1 divided by 3. So, probability that it is an even number when it is known that the outcome is a prime number is 1 divided by 3. A dice is rolled twice and the sum of the numbers appearing is observed to be 8. What is the conditional probability that the number 5 has appeared at least once? So here, since a dice is rolled 2 times, the possible outcomes and the number of elements in the sample space is 36. We have 1, 1, 1, 2, like that extra up to 6, 6. So we have two events here. Event A says that the sum of the numbers should be equal to 8. Event B is that the sum of the number, okay, the number 5 has appeared at least once. Here, probability of A is given, okay, it is given that number 8 has appeared. So what are the possible outcomes of 8? Sum should be 8. We have either 3, 5, 5, 3, then we have 4, 4, 2, 6 and 6, 2. Okay, these are the only possible outcome. So probability of A will be equal to 5 divided by 36. So we have to find what is the probability of A intersection B. What is the probability that both will happen? So the sum should be 8 and also 5 should appear at least 1. The possibility is either 3, 5 and 5, 3. So there are only two such outcomes, 3, 5 and 5, 3. So probability will be 2 divided by 36. Therefore, probability that event B will happen given that A has already occurred will be equal to probability of A intersection B divided by probability of A, which is equal to 2 divided by 36 divided by 5 divided by 36, that is equal to 2 divided by 5. Next, a box containing tickets varying from 1 to 10. A ticket is drawn at random from the box. The number is noted and kept back. Then second ticket is drawn. Find the probability that both the tickets drawn show odd numbers. Here, cards are drawn with the replacement. Okay. So when the cards are drawn with replacement, the events are independent. The first and second event are independent. So let us denote A is first card is odd number and event B is second card is also odd number. We have to find what is the probability that both the cards are odd number. That means event A and event B both should occur. Since the events are independent, by multiplication theorem, we have probability of A intersection B will be equal to probability of A into probability of B. Now, what is the probability of A? Out of 1 to 10, there are 5 are odd number. So, probability will be 5 by 10. So, 1 by 2. Again, probability of B. Since we are returning the card back, again there will be 5 odd numbers out of 10. So, 5 by 10 is 1 by 2. So, probability of A 1 by 2 into 1 by 2, that is equal to 1 divided by 4, 0.25. Okay, next, find the probability of drawing a diamond card in each of two consecutive draw from the well shuffled pack of 52 cards if the card drawn is not replaced after first draw. Okay, here cards are drawn without replacement. Okay, therefore, the events are dependent. Okay. So, probability that both the event will happen will be probability of A into probability of B given A. So, let A denote first card is diamond. So, probability of A, there are total 13 diamond cards out of 52. So, 13 by 52. Event B is second card is also diamond. Second card, drawn card is diamond. Now, we have to find what is the probability of B when A is already diamond. Since we are not replacing the card, probability of B given A, there are diamond is already picked once. Okay, event A is already happened means one diamond card is already removed. So remaining there are total 12 diamond cards and the number of card will be one less. That means 1 by 52. Therefore, probability of first card is diamond and second card is also diamond is A intersection B is probability of A into probability of B given A will be equal to 13 divided by 52 into 12 divided by 51, which is equal to, okay, we have 13 ones are, 13 fours are, here 3 fours are, 3 17s are, we can cancel 4 and 4, so we have 1 by 7 is 0.0588. So probability that both drawn cards in two successive uh, selection is diamond card is probability of 0.0588. Thank you.